My name is Jennifer Hodas, and I am a Commercialization Manager at the Pacific Northwest National Laboratory, or PNNL. PNNL is a DOE national laboratory located in Richland, Washington, and managed by the Battelle Memorial Institute. The technology I will present to you today is called the Retrocommissioning Sensor Suitcase, which is the result of a collaborative effort with LBNL and ORNL. Small commercial buildings represent a significant part of the commercial building space in the United States, yet they have not been able to take advantage of the energy savings to be had by retro-commissioning their facilities. This class of buildings, characterized as those with 50,000 square feet or less, typically do not have the budget or business economics that allow investing in the enhancements that retro-commissioning provides. In addition, they do not have in-house staff with expertise in building systems, so there is a need and market for a smart hardware and software solution that can be used by non-experts to improve building operating costs, comfort, and efficiency. That solution is the Retrocommissioning Sensor Suitcase. There are 5 main components to the suitcase system. First is the easy-to-install kit of sensors with supporting installation instructions. Each sensor can detect light, temperature, and vibration. The installation and tracking of these sensors is done through a handheld device that has a user-friendly interface to make this easy. At this point, the data control module in the suitcase coordinates the data and output findings, and the data is transferred to a computer where the data is analyzed and recommendations are generated for the user. Included in the analysis is an estimate of cost savings if the various recommendations are implemented so that the user may prioritize which changes to make first to their building. In order to see the Retrocommissioning Sensor Suitcase in action, we worked with 2 testing partners to try out our system for 2 weeks. One building was in Berkeley, California, with 7 packaged rooftop units with gas heat, of which 2 were monitored in the test. The other building was a bit larger and located in Lake Oswego, Oregon. This had 3 packaged rooftop units with gas heat, all of which were monitored in the test. This initial field test was successful, and we received some great market feedback. Overall, the feedback indicated strong market interest and broad applicability from potential users. While improvements could be made for a more seamless workflow, having this one-stop shop hardware and software system would enable penetration into the small building sector with reduced labor costs of retro-commissioning. We anticipate that our innovative system would deliver, on average, at least 10% site energy savings. For comparison, traditional retro-commissioning saves an average of 16%, but with roughly double the labor time and the additional expert costs. This effort has been supported by DOE's Building Technology Office thus far, and there is a unique opportunity for an industry partner to join in commercializing the Retrocommissioning Sensor Suitcase. We are looking for deployment partners who may be interested in licensing this technology to make our prototypes into 1 or more commercially available products within about a 2-year timeframe. If you are interested in either learning more or seeing a demo of the Retrocommissioning Sensor Suitcase, please feel free to contact me. Thank you for your time and interest, and I hope you consider working with PNNL on either this or any other scientific need you may have.